We are discussing IIT-JAM 2013 Modern Physics problem. Here we are discussing MCQ of 2 marks. The statement of the question is, a black body at a temperature T emits radiation at a peak wavelength lambda. If the temperature of the black body becomes 40, the new peak wavelength is. So we have to determine the new wavelength. Solution. According to Wien displacement law, lambda max into T is equals to B implies lambda max equals to B by T, where B is equals to 2.897 to 10 to the power minus 3 mK millikelvin. Thus, the peak wavelength corresponding to temperature T is lambda 1 max equals to B by T. Similarly, the peak wavelength corresponding to temperature 40 is lambda 2 max equals to B by 40, that is 1, 2, dividing equation 2 by 1, equation 1, we get lambda 2 max divided by lambda 1 max equals to B by 40 into B by T, or equals to lambda max equals to lambda by 4. So our answer for this question would be option D, lambda by 4. The statement of this problem is, electric field component of an electromagnetic radiation varies with time as E is equals to A cos naught omega t plus sin omega t cos naught omega t, where A is the constant and the values omega and omega naught are 1 into 10 to the power 15 per second, 5 into 10 to the power 15 per second, respectively. The radiation falls on a metal of work function 2 eV. The maximum kinetic energy of photoelectron is. So we have to determine the maximum kinetic energy. Solution. We have E is equals to A cos omega naught t plus sin omega t cos omega naught t, which can be written as A into 1 plus sin omega t into cos omega naught t, or equals to A cos omega naught t, where we have defined A is equals to A cos 1 plus sin omega t. Further, thus the energy of this radiation corresponds to angular frequency omega naught. equals to 5 into 10 to the power minus 5 into 10 to the power 15 per second or second inverse. Now the energy of incident radiation is E maximum equals to H cross omega naught, which can be written as (1.05 into 10 to the power minus 34 into 5 into 10 to the power 15 divided by 1.6 into 10 to the power minus 19 is turning out to be 3.30 electron volt. Thus, the maximum kinetic energy of emitted photoelectron is K is equals to E incident, or I would be changing here max to incident, minus W naught, that is 3.3 electron volt minus 2.0 electron volt, which is 1.30 electron volt. So thus our answer for this question would be option B. A beam of X-ray wave of wavelength 0.02 nanometer is incident on a free electron and get scattered in a direction with respect to the direction of the incident radiation, resulting in maximum wavelength shift. The percentage energy loss of the incident radiation is. We have to determine the percentage energy loss of the incident radiation. Now, solution. The wavelength of scattered photon according to Compton effect is lambda dash minus lambda is equals to lambda c equal into 1 minus cos theta. Further question says resulting in maximum wavelength shift. Wave shift delta lambda becomes maximum when theta equals to pi. So delta lambda equals to lambda dash minus lambda, turning out to be 2 lambda c. The energy of incident X-rays is EINC is equals to h nu, that is hc by lambda. The loss in the energy of the incident X-rays is at delta E is equals to hc into 1 by lambda minus 1 by lambda dash, or which can be written as hc lambda dash minus lambda into lambda dash lambda. The percentage energy loss of incident radiation is delta E by E into 100, which turned out to be hc lambda dash minus lambda divided by lambda into lambda dash into lambda by hc into 100, which is turning out to be lambda dash minus lambda divided by lambda dash is equals to into 100. Further, this modifies to delta lambda was equals to 2 lambda c, and lambda dash can be written as lambda plus 2 lambda c into 100, which is equals to 2 into 0.048 into 2 plus 2 into 0.048 into 100, turning out to be approximate 4.5%. Thus, our answer for this question will be 4.5. A free particle of mass m is confined to a region of length L. The de Broglie wave associated with the particle is sinusoidal in nature as given in the figure. The energy of the particle is. We have to determine the energy of this particle. Solution. The energy of a particle confined in 1D box is En is equals to n square pi square h square h cross square by 2ml square. Now we have to determine what is the value of n from this wave. Let us count out the number of nodes. The number of nodes in this wave is 1, 1, 2, 3, 4. So there are 4 nodes. The wave function would be psi of n minus 1. That means psi 3. Nodes, number of nodes minus 1. That means this wave function or this wave corresponds to wave function psi 3. So from the figure, the value of n is equals to 3. Thus, the energy of particle is psi is equals to 3 is, E3 is equals to 3 square pi square h cross square by 2 ml, or that is 9 pi square h cross square by 2 ml square. A particle of mass m is subjected to a potential Vx equals to ax square, where x goes from minus infinity to infinity and a is a positive constant in appropriate direction. Using relation del x del p equals to h cross by 2, estimate the minimum energy of the particle. So, solution, we have Vx is equals to ax square, the total energy of the particle is E is equals to P square by 2m plus Vx for a small change expressed in energy. We get del E is equals to del P square by 2m plus A into del X square. According to HOP, Heisenberg uncertainty principle, we have del X into del P is equivalent to H cross by 2 implies del P is equivalent to H cross 2 into del X. So substituting the value of del P in del E, we get del E is equals to H cross square by 8m del X square plus A into del X square. Now we have to determine value of del X where del E become maximum. That is d over del E divided by d into del X must be equals to 0 implies minus H square by 4m into del X cube plus twice A into del X is equals to 0 implies del X square equals to H cross by 2 root 2ma. Further, energy become minimum. Here I have incorrectly write maximum, where energy become minimum. Further, if we take it double differentiation, that is del square by del E by del square into del X, we would be having positive 3h cross square by 4m del X to the power 4, which is greater than 0. That means energy is minimum. Substituting the value of del X in del E, we get del E minimum equals to H cross square 2 root 2 ma divided by 8m H cross plus A into H cross by 2 root 2 ma, which give us H cross by 2 root 2 A by m plus H cross by 2 root 2 A by m, which is turning out to be H cross by A into 2m. Now let us check whether this energy is correct or not. We know it Vx is equals to Ax square, and which if that should be half m omega square, means A is equals to half m omega square, then corresponding to this del E is equals to h cross omega by 2. ठीक है, in ground state particularly. So h cross, if we substitute it 1 by 2m omega square divided by 2m, we would get h cross omega by 2. So our expression for delta energy, that is minimum energy, is h cross root over a by 2m is correct. A spaceship S1 leaves the Earth along with the positive x direction. Another spaceship S2 and leaves the Earth along the direction which makes an angle 60 degrees with x-axis. The speed of S1 and S2 are measured as 0.6 c and 0.9 c respectively by an observer on the Earth. Find the speed of S2 as measured by the observer in S1. So the speed of S1 is V1 is 0.62, speed of S2 is V2 which is 0.9. So now solution. Let us write the speed of S2 in component form. V2 is equals to V2x I cap plus V2y j cap. Further, V2x is equals to V2 cos 60 degree, that is 1 by 2v, and V2y to V2 sin 60 degree, that is root 3 by 2v, and the velocity of spaceship S1 is V1 is equals to 0.6 c. Now using the velocity addition, so for two different velocities along x-axis, we get, so we are determining velocity of the particle in the measured by an observer in spaceship S1. So Vx1 dash would be V2x minus V1 divided by 1 minus V2x by V1 into c square, which can be written as 0.45 c minus 0.6 c divided by 1 minus 0.6 into 0.45 equals to 0.205 c. Similarly, velocity along y-axis, we get V1y dash is to V2y 1 minus V2y v by c square into root over 1 minus V1 square by c square. So this gives us root 3 into 0.9 c divided by 2 into 1 minus 0.6 into 0.45. into root over 1 minus 0.6 square. This value turned out to be 0.854, or I would be writing here. This value turned out to be 0.854 C. Thus, the speed of S2 as measured by an observer in S1 is, I would be writing V2 x tracks V2 y dash. ठीक है, measured by an observer in S1, measured by an observer in S1. So V2 dash would be V2 dash x square plus V2 y dash square under root, which gives us 0.205 c square plus 0.854 c square equals to 0.878 c.